The periodic table project is an interactive wooden table that contains each of the known elements in the visible universe, or at least representations of them where elements cannot be obtained. And it is meant to educate the general public about the multitude of different elements that make up all of the visible universe, including every cell in your body. This project first began in the early days of chemistry team, way back in 2018, as a project idea suggested at a chemistry team meeting. After that meeting, the team began to research previous examples of interactive periodic tables.
Our first task as a project team was figuring out how big the table was going to be. We worked with Morgan, a fabricator at Chabot, since we had to think about how visitors would interact with it, as well as how much materials would cost. The math took a few months to complete, since we had to keep refining our estimates.
The final design ended up being an 8-foot by 4-foot rectangular table. Each square shown in the diagram was planned to be an open cell with a volume of about 6 cubic inches, while the dark spaces would be covered empty cells. We started making more tangible progress on the periodic table once we went out and bought materials. The dimensions here come from the calculations we did as a team, but we had to adjust them a little bit to account for what material sizes were actually available. Our construction process started with cutting the plywood sheets into planks. The periodic table's design was based on a bookshelf, so each plank would either be a horizontal shelf or a vertical divider. A honeycomb structure is a lot stronger than a bunch of horizontal shelves going all the way across with short vertical dividers in between to make the cells. So we cut notches in all the planks so that we could fit them together into one unbroken honeycomb cell structure. These pictures show the building process described in the last slide. So the ones on the top left are from the very first day of construction when we cut the plywood sheets into planks, and the rest are from the following weeks as we cut the planks, cut the notches, and then sanded the final product. Morgan supervised most of the construction work, but chem team members actually did most of the physical work ourselves. The next part of construction was building the frame. The process is pretty similar to building the rest of the table. We just had to cut the pieces to the right size, although with the frame, we also had to cut the ends at an angle so they would fit together into a frame shape. But once those planks were sanded, all we had to do was grab the honeycomb and assemble the full table.
After finishing the honeycomb structure, we had to put it together with a frame. Using a drill, numerous screws were used to stabilize the table. Although there were a few mistakes, we managed to create a table that could stand by itself. Here is the final product. We all were so proud because, after all, we managed to build an entire table out of several planks of wood. We know that there are 118 elements in a periodic table, and we also know that very few people are familiar with all 118 elements. To learn more about the elements, we decided to create an informational binder containing various descriptions of each element, such as size, shape, color, and examples of real-world applications. The binder will be with the periodic table, so visitors can always take a look to learn about the elements. During our team science night, the periodic table group decided to split into 3 smaller groups. The first group introduced the team's overall goal to the visitors. The second group led the element matching game, and lastly, the third group introduced the table to the visitors. For our first teen science night, we decided to create a demo about different elements, so we came up with an element matching game. We would have the visitors match each household item we brought with corresponding element cards. If they managed to complete the activity under the time restriction, then we will give them a prize. 2019 was the 150th anniversary of Periodic Table, and as a result, Chabot's annual Starlight Gala featured Element as their theme. Chemistry team was able to bring their periodic table as well as their element matching game to show to the audience. Interestingly, Elsa, our team manager, was able to bring two samples of safe uranium. Compared to other elements, the samples exhibited neon green color when they were exposed to a light source.
Having finally finished constructing the wooden structure of the periodic table, it was time to polish up our woodwork and strive towards a finished product. We did so by manually sanding the entire periodic table and then priming it. We had intended for the periodic table to be completely painted and close to completion by now. However, due to the COVID-19 closures, our physical work on the table came to an abrupt pause. In the picture shown on screen, members of the periodic table team can be seen sanding the wooden structure of the table. Over the course of several weeks, members of the team fully sanded the table, removing or covering up all of the flaws and imperfections of the wooden frame of the table. We then primed the table with priming paint. The initial layer of primer allows for smoother, more consistent painting of the outer coats due to the superior adhesion created by the primer, while simultaneously providing greater durability and resistance to the outer paint layers. The priming process was a surprisingly long one, largely due to the gloomy weather, which caused the primer to dry very slowly. Furthermore, the concave nature of the many holes or cubbies of the table made it difficult to fully paint, requiring much effort and some ingenuity to fully paint the inner sides and edges of each box. The periodic table team spent many hours priming, suited in lab coats to protect from the primer paint. We never got to paint the outer layers of the periodic table, though we did finish sanding and priming the table before the closures. Once it becomes possible, we will paint and finish up the periodic table.
With regards to the color scheme of the table, we'd already decided to use cool colors like blue and purple for the table since the Chabot Space and Science Center already has a lot of blue in it. That's not to say Chabot is a sad place. Later, a few members of chemistry team went to Home Depot to get paint chips and shuffle them around to find an arrangement that would suit the periodic table. A few Chabot staff members were also asked for ideas regarding the color scheme of the periodic table.
Each element on the table has an element card that describes it in terms of its physical properties. Each element card will have the atomic number, element symbol, element name, and atomic weight of its element. The atomic number is the number of protons in an element. The element symbol is a letter or two letters that are used to identify a specific element. The element name is the full scientific name of the element. Lastly, the atomic weight is the combined mass of an atom's protons, neutrons, and electrons. The current plan is to etch the element cards using a laser cutter. Once we figure out how to label the elements and cover the table, the empty cells will be covered with plywood and painted black to match the rest of the frame. We might put a plaque meant to commemorate our team's work on the periodic table in an empty space on the plywood.
I've been part of chemistry team since it began in 2018. It was my junior year of high school. I was taking honors chemistry, and my chem teacher made the subject sound so interesting that I wanted to keep exploring it through Chabot as well. I was initially kind of disappointed that I couldn't join Astro Team, but in the end I'm really glad that I stuck with Chem Team. It was super cool getting to build the team from the ground up, and I'm really proud that I was able to help take the interactive periodic table from a random idea someone brought up when we were figuring out what to do with our team to a nearly complete Chabot exhibit. I've always thought the periodic table was super interesting, and I like being able to connect such an important scientific concept to everyday life through the objects inside the table. I really enjoyed presenting the periodic table at Teen Science Night and the Chabot Gala, but I think my best memories were actually from construction. I went from being really unsure around the power tools to being in the workshop every other Saturday. Working on the periodic table project helped me gain a lot of confidence in my own abilities. I learned physical skills like how to build an exhibit, but I also learned interpersonal skills like how to be a better team member and leader. I think the most important thing I learned was that to get a big project like this done, you have to keep working no matter what. Sometimes we had setbacks because someone we needed to talk to wasn't available or we didn't have access to certain materials yet, but we had to keep finding ways to be creative and move forward. And we're still doing that as we work on the project from home.
I have been in the chemistry team since it started in 2018. When I first joined Chabot, I was looking for something chemistry related because I have always been fascinated by molecular interactions. So when I heard about the chemistry team, I immediately decided to join. I chose to participate in this periodic table project because I wanted to learn more about the elements, and my favorite memory would have to be the time when we finished building the table. I was so proud of what I had done when I saw the table stand by itself. Lastly, the project has taught me that cooperation really makes the progress quick and easy.
I became a GE relatively recently in the fall of 2019, and soon after joined chemistry team because I wanted to dive deeper into my interest in chemistry. As a new member, I chose to participate in the periodic table project because it just seemed to be the most newbie-friendly project. However, I also found the project easier to work on with other people since it's a more tangible product, and I also just didn't know much about biodiesels. My favorite memory from working on the project was probably first priming the table because putting paint on wood was just satisfying for me, and it also seemed like we were making a lot of progress in a relatively short amount of time. Over the time that I've spent working on this project, it has taught me that things actually take time, commitment, and effort to complete. That I actually have responsibilities, and that my efforts or lack thereof affects the entire project. That the saying "many hands make light work" is really true, and that sanding, priming, and painting something can actually take a long time. I think it took us 3 weeks just to sand and prime the table. We didn't even get to painting because of the pandemic. We had to close down. Um, but however, I think my favorite lesson is probably that I have a part to play to support the projects that I'm a part of, and that my efforts affect the entire project, even showing up in the final product.
I joined the chemistry team because I wanted to learn more about the elements and how they interact with each other. I chose to do the periodic table project because I had never done anything like it before. It was cool to learn about the properties of each element on the table. My favorite memory of working on the periodic table was when we finally finished sanding it. This project has taught me more about the properties of the elements. It has also taught me how to be more patient, as preparing the table takes time. From this project, the best thing I learned was how to sand and prime wood, as I can use this skill when building things in the future.
Sometime after joining Chabot's Galaxy Explorer program during the summer of 2019, I found out about the various teams associated with Chabot. While I was, at first, unsure of which team to join, I was soon drawn to the chemistry team because I had just started taking honors chemistry at my school, and so I thought that I could apply my newfound knowledge from my class to chemistry team, and vice versa. I was rather uncertain of what to expect from the chemistry team, however I was pleasantly surprised by the hands-on approach to chemistry taken by the chemistry team, which sharply contrasted the primarily theoretical nature of my chemistry class at school. As such, I decided to join the periodic table team because it seemed to strongly embody this hands-on approach. Additionally, as a new member of the chemistry team, I wanted to join an already established project so that I'd get to know the team and its members and its mission. The most memorable part of the periodic table project was the priming process, largely due to its lengthiness. While the act of priming itself had little to do with chemistry, I found the teamwork and cooperation, coupled with a sense of collective progress, to be novel and impactful. As a result of this, I enhanced my teamwork skills and my ability to think holistically. My most prized result of this project is a sense of long-term thinking and planning, which was highly characteristic of the periodic table project. I hope to make use of this long-term thinking and planning in my everyday life. Regarding scientific pursuits, I gained a greater understanding of the periodic table and its many elements. Overall, this project provided me with a better understanding of project management and of the elements of the periodic table, in addition to various life skills, for which I am very thankful.